Here's a fantastic way to end this unit. I really like this question because, look, here's an original function, blah, 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 and we're going to compare it now to a radical of the same function. So I want to see what happens to this thing, and I want to be able to compare some things to it. Okay, so if you look at the first question, it says, oh, okay, let's identify the values of x which the radical is defined. What does that mean? Values of x, you're just finding the domain. That's all you're looking for. You're trying to find the domain of these two functions, that one and the radical of it. Okay, simple enough. Let's do this. Well, first things first, take a look at this guy. You know that that's a linear function. We could actually write this a little bit nicer. We can write it as y equals to minus 2x plus 4. Remember all that wonderful stuff that we learned in grade 10, which was, of course, there's 4, 1, 2, 3, 4. There's the y-intercept, down 2 over 1, down 2 over 1, and we have this beautiful value that's looking like that. So obviously, in this particular case, x could be whatever you want it to be, right? X could be any member of the reals, right on. But look what happens. You know and I know from experience when we take the square root of something, all of these values under here disappear. So there's our nice critical point right there. But what else means? What else does this mean when you're defining the radical? Well, you know and I know you can't take a square root of a negative. So that means 4 minus 2x, this equation underneath the radical, has to be greater than and equal to 0. It has to be a positive number. And if you solve for this, it becomes really easy. Subtract 4 from both sides. Yippee skippy. You got minus 2x greater or equal to negative 4. And now you divide. Now that's the trick. When you divide by negative 2, look what happens. That cancels out. That becomes an x, but negative 4 divided by negative 2 now, if you think about it, it's just plain old positive 2. But here's the other important thing. When you divide or multiply by a negative, the inequality has to be flipped. Because if you think about this now, look at this guy in terms of a transformation. Look at this. This is the square root of minus 2x plus 4, which is just this rewritten. You have to factor out that negative 2 here to give you, of course, an x minus 2. And look what this means. You got a horizontal reflection and stretch. And guess what? It's moved over 2 units to the right. So if you think about it, this was right here at positive 2, which is defined by here. Don't forget this is a horizontal reflection, so you're going to go out that direction. Got it. Right? Right. Now, also be careful because on a diploma exam, they love questions like this because a lot of people forget to do this last step. So they'll give you something that looks like this. They'll go, oh, your selections of A, B, C, and D on your multiple choice are going to look like this, okay? Right? So one of the selections could be, yep, like this, or they can play around with you and get you to kind of start doubting yourself and going, do I flip that or don't I flip this? And one of your values is going to be this. Oh my goodness, but we know we had to flip it, so that means this is wrong. And then the other thing that they're going to play around with, of course, is this idea of the negative divided by the negative. So they're going to give you a choice here, and they're going to say, x is going to be like this, but it's going to be a negative 2. And your last choice then is going to be x, and they're going to flip it, and they're going to make this negative 2. Well, you know from being smart that a negative divided by a negative is a positive, and when you divide by a negative, you flip that inequality. So all of these other guys are wrong. That is your right answer. Watch out for that. Okay? Now, the second thing that they're going to look for is they're going to look for this. They're going to say, okay, what is the value of the invariant points? Now, you remember from a podcast way, 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 way long ago here that your invariant points happen when y equals to 0 and y equals to 1, right? Because if you think about the graph that looks like this, it's starting at 2, and this one was way up here at 4, it goes like this, and then your other graph started here, and then just kind of doubled in that direction. Remember, that value at 1 and that value at 0 are incredibly important. Those are your two invariant points on the graph. All right, so all you have to do is just take this guy here and you just have to solve for it. It becomes very, very easy to do. Now, what do you solve for? Do you solve for the radical or do you solve for the original equation? Well, actually, it doesn't matter because they're invariant points. They work on both equations. I think personally that y equals to negative 2x plus 4 is much more easier to solve than anything else. Okay, even with the radical, I'll prove it to you. Y equals to the square root of negative 2x plus 4. I'm going to show you that that actually gives you the same answer. So let's try. For invariant point 0, 0 equals to negative 2x plus 4. Bring the 4 over, that becomes negative 4 equals to negative 2x. Divide by negative 2, divide by negative 2. X equals to, of course, 2. So your point then is 2 comma 0. Yeah, no kidding. I've known that for a long time already. But now let's look at this point here. Aha. Okay. Oh, by the way, you're probably wondering, can I do it for this one? Well, yeah, no kidding. Watch. 0 equals to the square root of negative 2x plus 4. How do you get rid of the square root? You square both sides. So if you square both sides, look what happens. What's 0 squared? So it looks like we're right back to where we were right there and there. Right? Yeah. So it doesn't matter. Now, here we go. Let's go and find out what this looks like when y equals to 1. Oh, this will be interesting as well. Okay, so here we go. We have a value here of y equals to negative 2x plus 4. Let's make the y equal to 1. Okay, 1 equals to negative 2x plus 4. Now let's start solving this guy. And again, it doesn't matter because if you're going to use the square root, if you're going to use the radical function and you square it like we did here, what's the square of 1? 1 squared is still 1, so you don't care. Whether it's the original function or the radical function, it doesn't make a difference. Okay, bring the 4 over. So we're going to subtract 4 from both sides, making this a negative 3. Okay, equals to, oops, shouldn't be a comma, should be equals to negative 2x. Divide each side by negative 2. X works out to be 3 over 2, a positive value. So at 3 over 2, 1 is the other invariant point. Now, I know what you're saying. You're probably saying to yourself, prove it. Can you actually put this on a graph and prove it? Well, actually, yes, you can. Check out what I have here on your calculator. So what I did on your calculator is I put the original in, just like we always had, and then I used the VARS idea. And then I put the original under the square root. Piece of cake, right? Right. Then I'm just going to hit graph, and there it is. Now, if you can't see that very well, of course, you can use that zoom box idea, and that's exactly what I'm going to do. I'm going to zoom box it. I'm going to get nice and close here so I can see everything, right? Nice and close. Anchor it, boom. I can either move up or down or right or left. I'm going to move right on this one first. So I'm going to move right over to here like that, just a little bit more so I can see it. And then I'm going to move up. Yes, there's our box that we're looking at right there. And I'm going to hit enter. And there's my nice graph. So you can see that there's that y equals to 1. There's our one invariant point, and there's our other invariant point. We know what that is already because, of course, that is the x-intercept on our original graph. But the one I'm interested in is that one. Remember how to figure that out? You go second, you go calc, you find me that intersect, which is 5. Okay? Mouse up close to that point if you want. Okay? Get up there. We go. Come on, you. There it is. Hit enter, hit enter. Of course, it's going to say guess, and look what you have. Remember, it was 3.5, 1.5. So you can actually verify this now using your calculator, and it works out incredibly well, doesn't it? What a great way to finish this section of the unit.